Here's the stabilizer that we joined and left to cure the other day. So it's been under the blanket for about 20 hours at 110 degrees. Blanket turned off and everything's cooled. So the first thing we do is check the control sample of the splooge that we used to join everything. And you can see that it's been rolled it out to a thickness that represents what we used in the joining, and so it didn't cure at a different rate than we used inside. And we're looking for it to be fully cured, so we should be able to snap it like that. You can see it's cured all the way through. So, and these are icing bags that I get from Aircraft Spruce in lots of 100. They're really affordable, disposable, work really well for that join that you saw. So let's get this thing out of the blanket. Get rid of that. And then I can unbolt it. You might have noticed on here from the joining that it says do not heat above 100 degrees, and that's a factor of the mold construction. This is a pretty simple mold. It's just a buildup of glass and resin. There's no tooling coat. There's no registration, unfortunately, and they're about probably half, or a little more than half, as many bolts as I'd like to see. Ideally there'd be a few more than that, but the flanges are pretty thick, so it's not too big of a deal. These are just 1/4 socket head bolts. It looks like, there's holes here at the leading edge in these corners, but there's no bolts there, so really put some in there. When I said this mold doesn't have any registration or index pins, that's normally you'd see that as half domes or some kind of feature that's built into one side of the mold on the flanges with a matching feature on the other side, and that keeps the two halves indexed when you join, because you have a fairly critical leading edge alignment that you're looking for. So this doesn't have that. And I didn't make these molds. These are going on 20 years old. But one thing this does have is that the blind nuts that receive these bolts, the shank on those is deeper than the mold flange. So they do serve as a registration of sorts. Over time these holes get a little bit bigger, but in this case they're still working well enough, and it's not a high volume piece. I don't make a lot of these. So that's it. All the bolts are out and we're ready to separate. You get a pretty fancy tool for that. Screwdriver. So we just work our way around. We don't want to stick it in there too far and damage the part. I do have wedges and other things that are designed for this, but in this case, screwdriver is going to work fine. There's usually some temptation here to just bust it apart and see what kind of piece you have, but you really have to be pretty careful when separating molds. So here what we have is the bottom side, and the piece is stuck in there. It's fairly random which side it sticks in. So there's the inside of the top. You can see that's just a plain resin and glass layup. There's no tooling coat, there's no graphite powder to color the mold. It's a very simple piece. They've used some splooge here in the corners, just because the glass won't take that kind of wrap. Still in really good shape. Makes some good parts. Got a couple of nicks out of some edges here and there. Over here it's got some cracks. Those are getting ready to go, but still very serviceable. A lot of parts left in this. There is, so that's the finished top side of the stab. Still in the bottom side. You can see here we've got a little bit of squeeze out. That's about perfect. Most of that goes inside and maintains the bond. And then we have some overhang here from the bottom surface. So what we don't want to do here is stick anything under there. The best way to get a part out of a mold like this is to twist the mold. And something like this, of this size, we can do it single-handedly. So that's got most of it right there. Just hanging on by that edge. There you go. So that's the bottom side, and this is blue 3M. I think they call it fine line tape. That's 3 layers, and that creates this trench in the bottom surface, and that'll get cut loose on the leading edge to form the movable portion of the elevator. And the reason the trench is there is that you can add a wiper to clean up that joint or to close the gap when you cut that open. Now, some guys bond that wiper in there. That's a little extra work. You have to install that and do some body work to get it all flush and make sure it clears and so on. A lot of guys will just cut that open enough to get the range of motion you need and then put some external gap seal over it. Both methods work fine. So a little bit of splooge here on the leading edge that'll clean up. And then the trailing edge, I don't know if you can see that, but the bottom side is difficult to trim in the mold to the true trailing edge size just because of the way the mold's made. On the top it does get trimmed flush, and that gives an easy reference for trimming the back of that. There's no hinge. The hinge is built in here. It wasn't very noticeable in the joining video, but there's a 1-inch wide aramid or Kevlar strip in there to serve as a live hinge between the elevator spar and the drag spar. So that's that part. That's probably 12 or 14 ounces. Definitely overbuilt for the flight loads that it needs to see. But this is built more in mind of handling. Stabilizer sees a lot of handling on the ground and during the run-up. So we build it more for that. And the Ashley tends to build quite nose heavy. So any weight in the tail is helpful, and it's good for that to go into the structure. So that's pretty much done. All we have left to do with that is clean up the flashing.